Today we're going to solve a ratio problem, and we're going to use tape diagrams to figure it out and explain our reasoning. So the problem says the ratio of frogs to turtles is 3 to 5. If there are 55 turtles, how many frogs? So the first thing I'm going to do is draw two parts of a tape diagram to show that ratio of 3 to 5. So I'm going to draw one that is 3 boxes long to represent the 3. And I'm going to write an F right here because that tells me that there are 3 frogs. And then I'm going to make another one that is 5 boxes long. And that's going to represent my turtles. Now, if I look at the problem, it says there are 55 turtles. So this entire tape diagram represents 55. If I know that that entire diagram represents 55, then I can take 55 divided by the 5 pieces that it represents and find that each box represents 11 turtles. So I can put the 11 in each box. And if I know that each of these boxes represents 11, then since these are the same size, I know they also represent 11. And if each of these represents 11, then I can find the number of frogs by adding these together or doing 11 times 3 to get 33 frogs as my final answer to that problem. Now I can also look at this and I can determine that an equivalent ratio, 3 to 5, is also equivalent to 33 to 55. Those are equivalent ratios. If I wanted to write a different ratio with the same information, I wouldn't just change the form, I wouldn't change the numbers and find an equivalent ratio. I would go back to the beginning and know this is about frogs and turtles. A different ratio that I might write could be the ratio of turtles to frogs. Turtles to frogs would be 5 to 3. Or I could say something like the number of frogs to animals in this problem. And the number of frogs is 3, and the total animals is 8. So I'm looking for a different ratio. It would be something like one of these two.